Hey everybody, this is lecture 12.5, special logarithms and the change of base formula. First we're going to talk about what's called the common logarithm. So let's get some handwriting that works here, Jenkins. The common logarithm, we can't spell, logarithm, is known as the base 10 logarithm, which is log base 10 of x. Now, when we use log base 10 of x, we actually don't write the base. So that's why this one's special. When we just write log, we mean base 10. So even though no base appears, we understand that the log is base 10. Now, why base 10? Well, because our number system is actually base 10. Since you've been very young, the numbers that you've been writing down, large numbers, small numbers, and the way that we use placeholders are base 10. That is to say, when you write down a number like 2,307, what you mean is 2,000 plus 300 plus 7, which is 2 thousands plus 3 hundreds plus 0 tens plus 7 ones, which can be written as 2 10 to the third powers plus 3 10 to the second powers plus no 10 to the first powers plus 7 10 to the 0 powers. Now, we're not going to get into too much detail here with that, but this is a number that is base 10. The numbers that you're used to writing are base 10. In fact, we can even make this go a little bit further. Whoops, let's see. Undo that. We can make this go a little bit further by putting a decimal on here, 0.32, and this is plus 0.3 plus 0.02, which is plus 3 times 10 to the negative first power, or 3 times 1/10, I should say, right here at this step. 3 times 1/10 plus 2 times 1 over 100, which is plus 3 times 10 to the negative 1, plus 2 times 10 to the negative 2. And so the idea here is we're writing everything as multiples of base 10. And so log base 10 is actually pretty easy to calculate. For example, when we write something like evaluate the log of 10,000. Well, that's the number of powers of 10. This is actually log of, let's see, the base, even though it's not written here, is understood to be base 10. And our argument, 10,000, is 10 to the fourth power. And so what we're looking for here is the power that turns 10 into 10 to the fourth power, and the result there is just 4. Or if you like, the stone-cold number of zeros that we have on the end of this number, 1, 2, 3, 4. So that's pretty straightforward. Yeah, man. Okay. However, if we try to evaluate the log of a number that is not base 10, the log of 12, this is the log. Oops, let's write it as a log here. That looks like a 10. The log of the unwritten base of 12. And the unwritten base here is 10. And that is the power that turns 10 into 12. Now, I don't know what that is off the top of my head. However, we can actually use our calculator. On your calculator, you should be able to find a log button, L-O-G. Try to find that now. It might be a secondary feature. It might be something like you might have to do the second or inverse button, and then something like 10 to the x, depending upon what kind of calculator you have. But it turns out that if you calculate this here, let's see, the power required to turn 10 into 12 is log of 12 is approximately 1.07981 and some change there. So it's a little bit bigger than 1. And so the power required to turn, sorry, it's a little bit bigger than 10. 12 is a little bit bigger than 10. And so the power required to turn 10 into 12 is a little bit bigger than 1. Now, I keep saying it's understood that the base is 10. What do I mean by that? What do we mean by it is understood that the base is 10? Well, what I mean is when we don't write it, whatever the argument is, it's understood what that base is. And by that, I mean, when we write expressions in mathematics, and this happens a lot, it's just understood that there are certain values in play. For example, if I write y equals x, and I ask you, what power of x is that? Probably most of you would look at that and say, well, it's the first power. And I said, but I didn't write it. How do you know it's the first power? And you say, well, when it's not written, everybody just knows it's 1. You also know that this is a coefficient of 1, even though it's not written there, and we're actually adding 0 to it. So, there's a lot of different values in here where it's understood. So, in each one of these cases, it's understood that the coefficient is 1, it's understood that the power is 1, and it's understood that we're adding or subtracting 0 because there's no term there. So that's what we mean by it's understood that the base is 10. Yeah? Okay. So anyhow, there's that. Now, that's our first special logarithm. So can I move this down a little bit here? Hold on one second. Let's see if I can move this down here. Just a little bit. There we go. So that I can say that we're starting off here with special logarithms. And there's two. This is actually the first one, the common logarithm.